Alright, so this is your introduction to projectiles and projectile motion. First things first, projectiles. Up to this point, we've only dealt with things that move in one dimension, and now we're actually taking a look at things that move in two dimensions. Projectiles, they move both vertically and horizontally, and at the same time. Now, by definition, a projectile is an object that is in only acted upon by the force of gravity, or an object in which the only force acting on it is gravity. So you guys did labs that took a look at these things, projectiles, and what you found out is that by their definition, like it said, the only thing acting on these is the force of gravity. So again, I asked you to draw a free body diagram of what an object undergoing free fall looked like, or an object that looked like, or that was under projectile motion looked like, and it should have drawn just a simple force of gravity acting on the object. Again, there's no applied force because there's nothing pushing it. Even though it's moving, there's no, we typically neglect air resistance here, and so that's something that, again, we're probably going to have to do throughout this unit, and you'll be told so by problems and things like that. But the only force is the force of gravity. Okay. Now, the other thing that you learned about in lab is that the vertical and horizontal motion are independent of one another. Okay. What that means is they act different. And the reason is because one has an unbalanced force acting upon it and the other doesn't. Okay, horizontal motion, there's no force acting on a projectile horizontally. We know that it's actually started moving by an unbalanced force, but while it's in the air, there's nothing pushing it, and so therefore, horizontal motion has no unbalanced force. Vertical motion, on the other hand, we have gravity, and gravity is continuously pulling on the object because the object has mass and it's on Earth. So therefore, our unbalanced force here in this situation is the force of gravity. Now, we learned our last unit, with unbalanced force comes acceleration. And so, with no unbalanced force in the x direction, we have no acceleration in the x direction. And at the same time, in the y, we have an unbalanced force of gravity, and therefore, if the force of gravity is our unbalanced force, then the force of gravity produces the acceleration of gravity. So I'm actually going to call this little g, because our acceleration for vertical motion is always going to be gravity, which is 9.8 meters per second squared. Lastly, our velocity. Okay, again, because this acceleration is 0, that means velocity is constant in the x, whereas in the y, it's accelerated. Okay, we have two separate equations for these, and let me explain these two a little bit. Okay, first the equation for, again, this is for our x direction, and this is for our y direction. Okay, our x direction, typically we use what we call the range equation, and it's delta x is the velocity in the x direction times the time. Now, range essentially deals with how far the object will travel in the air, distance. If I threw a football and I asked you how far did I throw it, your answer would be the delta x, the range of the football being thrown. Okay, now delta y on the other hand, that's talking about how far it's moved up or moved down as it's thrown. Okay, or as it undergoes projectile motion. So we find that, again, you'll recognize this because you actually have one that is delta x vit plus 1/2 at squared, but this equation is specific to projectile motion, where we're talking about the change in the y position is equal to the velocity initial in the y direction times the time it's in the air plus 1/2 times the force of gravity, or acceleration of gravity, times the time squared. Now you'll notice up here I have this little same thing, and all that that's showing is that although my horizontal motion and my vertical motion are completely independent of one another, the fact that they have the same exact t means that I can go back and forth from one another using our time, which will come into play down the way. Now, I want to show you a couple of just different examples again. No matter what, whether it's dropped or thrown, okay, in the vertical direction, the only thing acting on this is the force of gravity. Okay, so if you notice like this comparison of a boy who throws the ball straight up or the boy who throws it horizontally with the same vertical velocity component, the ball is going to be in the same vertical location at different times. Okay. Again, notice the spacing here, although they don't perfectly line up to what's going on here, the dropping of this ball is the same spacing as the ball that's been thrown. Okay. And actually, that leads into a classic experiment that has talked about quite a bit, and actually the Mythbusters recently did. Bullet fired, bullet drop. So if I shoot a bullet out of a gun, and at the same time I drop a bullet, which will hit the ground first? Well, based off of the physics that we know, the bullet fired will actually hit the ground at exactly the same time as the bullet that was dropped. And this picture kind of shows how, because again, we know this to be true only because no matter what's going on, after the bullet leaves the gun, the only force acting on it is the force of gravity, and it acts in the vertical direction, which means it should hit the ground at exactly the same time as a dropped object. Now, I guess I'll refer you to that in just a second. Now, here's a video of a tennis ball being fired and dropped at the same time. Okay, now the one that's rolling on the table is the one that would be fired, and the one that he's holding would be dropped. Now, again, this isn't perfect, but it is a good example or a good demo of what happens. So there it is, full motion, and you can hear the two tennis balls hitting the ground at exactly the same time. We'll do this again. So again, here it is, fired and dropped, and again, there they are, almost at the exact same point at the exact same time, and that's because gravity is independent. It does not care if you're moving or not. Okay. Another really good example, and I guess I'll point you to this right now, is on our school website, our course site. And the Mythbusters did a big thing on this. It's going to be Mythbusters bullet fired versus bullet shot. Check this video out because it teaches what I'm talking about very, very well. Okay, so again, that's under our course site. That is your introduction to our projectile motion. Okay, again, I'll put those notes back up one more time so you guys have them to see, to go off of, because I think that's something that you should have in your notebook if you don't already, along with this chart that I have down below. So here's the top part of the notes, and again, down below, that nice little chart. I suggest having this as well. If you have any questions, like always, email. Enjoy projectile motion.